Guys, welcome to today's lesson. So today we're going to talk about how we can create optimal area or maximum area and perimeter. Usually in this case we're talking about minimum perimeter. So the idea is that, like, say you want to fence in an area, you want it to be the biggest possible area that you could possibly make, but you want to spend the least amount of money on enclosing it. So you want the least amount of fencing, but you want the biggest amount of area. And we're going to talk about how you can do that. But we're going to do a little bit of an investigation first. So suppose you have 24 1 meter sections. So that means you have 24 meter sections altogether, and they're in 1 meters each. And we're going to enclose a rectangular garden. What is the maximum area that you could enclose? Now, the idea right now, all I want you to do is construct as many rectangles that you can using the 24 1 meter sections. So you're going to have to just do a little bit of math, make a bunch of different rectangles, and then decide what your length and width is for each of them. Keep in mind that you only have 24, so the amount that goes around the outside of your rectangle is only 24. So I'm gonna pause the video. I'm gonna do a couple, but I'm gonna let you guys do that as well. So pause the video here and kind of come up with as many as you can. Okay guys, so I just did this on a different sheet of paper, but I did a couple of examples. So you can see here my first one has a width of 1 and a length of 11. And you'll notice it all adds up to 24. 1 plus 1 is 2. 11 and 11 is 22. So 22 plus 2 is 24 altogether. Same with number 4. We have 4 and 4, 8 and 8. 8 and 8 is 16, plus another 8 is 24. So all of these are different examples of rectangles that add up to a perimeter of 24 around. Notice that 1 and 5 are very similar, but in this case the length is 1 and the width is 11, whereas in number 1 the length is 11 and the width is 1. So they will give kind of the same measurements, but they're oriented a little bit different. So they are actually two different rectangles. So be cognizant of that and keep that in mind when you do this. Let's go back to the note. And it says that create a graph, fill in the following chart with your rectangle dimensions and calculate the area and perimeter. Create a graph of area versus length. Draw a small curve through the points. So you can do that now. So you can start filling in a chart that's similar to this. In the first one, my length was 1. And my width was 11. In the second one, my length was 2 and my width was 10. Then I did 3 and 9, 4 and 8. And you can, if I calculate the area of it, 11 times 1 is 11 squared, meters squared. 2 and 10 is 20. So just do a couple calculations. 3 and 9 is 27. And you'll keep going. The perimeter, obviously, because we've already done it, it's always 24. Or they should all be 24 because that's our maximum that we have. Or that's what we have to work with. So we'll just leave that as that. Then I want you to graph it. 4, 5, 6, 7, 8. So we'll graph them. And I'll let you do that and I'll come back and I'll show you what my graph looks like so you can compare it with your graph. So pause the video here to actually fill that in. Okay, so coming back, if you've done your graph correctly, you'll notice that and connected the lines, you'll notice that you get this nice smooth curve that looks like a hill and comes back down. So it's a nice parabola that we have here. What are the dimensions of the garden with the maximum area? Did you use the table or the graph? So if you look here, probably at point, I think it's 6 and 36. if you've done it correctly, you have a graph, and that's the highest point it goes to. So you can, and you'll have it on your graph as well. You probably have somewhere that your dimensions are 6 and 6, 36, 24. And you'll notice that using the table, you get that 6 by 6 gives us a maximum of 36 meters squared. Or on the graph, you get 0.6 and 36 is the maximum. So you know that 36 is the maximum area. Did you use the table or the graph? You can decide which one is easier for you. Lots of people just say the table is because you can see it right away. But it's possible you might miss some in the table if you didn't do all of the possible rectangles. And then the graph is a little bit easier. Either way, you should still get the same answer. So that's fine. Let's move on to part B and see what happens with this example. So suppose you want to build a rectangular patio with 36 1 meter square patio tiles. So those are square tiles, and you have 36 square tiles. What is the minimum perimeter the patio can have? Each square tile represents a patio tile. Construct as many rectangles as you can using all 36 tiles. For each rectangle, record the dimensions, area, and perimeter in a table. This is going to be similar to the last investigation, but it's a little bit different. So I'm going to show you quickly how you can start doing them. But pause the video here and see how many you can come up with. Okay, so here's a couple of examples that will make 36 tiles in total. You could have a patio that measures 3 tiles on one side and 12 along the other. That gives 36 tiles altogether because 3 times 12 is 36. You could have one that's just 2 tiles wide and 18 tiles long for a longer patio that also gives us 36 tiles. Don't forget that you can also, if this is the length and the width, you can change it to make that third one go this way. So you can kind of have a longer deck coming out, but it's more narrow. So in this case, it's 3 wide, but 12 long. They look the same, but they're oriented. Again, they're oriented differently, so we can say that they're different. We're going to do the same thing. So you'll notice that all of these have the same area because they're all 36 meters squared. But you'll notice that their perimeter is a little bit different. For example, this one is 3 and 3, which is 6, plus 12 and 12, which is 24. So this one's 30 meters around. This one is also going to be 30 meters around. That's okay. But this one's 2 to 18 and 18. 18, 18, 36 plus 4, which is 40 meters around. So if you're looking at it, this one, number 2, is actually going to take more material to go around it than either 1 or 2. And there's other examples, so I want you to come up with them. And we'll do the same thing. We'll start to fill in the chart. I did some of these already. And we'll just keep going. You can keep going. They're all 36 meters squared around. Okay, so if you filled in the chart and did your perimeters, you'll notice all of the areas are the same, but the perimeters are different. And you'll notice that it is the 6 by 6 one that's 36 meters but has a perimeter of 24. And then if you do the graph, you'll notice here at 6 and a perimeter of 24. So this is the perimeter here and the length. So again, in this case, you have the minimum perimeter, or the smallest perimeter that you can possibly have. Notice it is the 6 by 6. So in both cases, For the maximum area, you had a square that was 6 by 6. And for the minimum perimeter, you also had a square, and in this case was 6 by 6. That's really interesting. Because moving to the next page, among all rectangles with a given perimeter, you'll notice that a square has the maximum area. And among all rectangles with a given area, it is a square that has the minimum perimeter. Now, I say rectangle and square, and I have in classes been like, had students say, but wait, miss, a square is not a rectangle. So I have here, yes, a square is a rectangle. It's just a special rectangle in a case where all the sides are equal length. It's still considered a rectangle. It's just special, which I don't know why, but a lot of students haven't been taught that. They are two of the same things, just the square is a special rectangle. Okay, so let's look at an example and see how we can actually use this and what kind of calculations we need to do. So example 1 says, what are the dimensions of a rectangle with perimeter 20 meters and maximum area? What is the maximum area? So in this case, I go right to consider, because I just told you we're looking at a square, because a square gives maximum area. So if the perimeter is 20, what square can I make with that? So the thing that you want to do is take your perimeter and divide it by 4 so that you have 4 equal sides. And in this case, we get 5. So we're going to have a square that's 5 meters on each side. What is the maximum area? So the area, really simple, we'll do length times width, which is 5 by 5 in our case. So 25 meters squared. So the biggest area we can possibly have with this perimeter of 20 meters is a square that is 25 meters squared. Let's look at B. It's a little bit different. What are the dimensions of a rectangle with area 45 meters squared and minimum perimeter? Minimum perimeter, again, I'm going to think square. Now, our rectangle or square has an area of 45 meters. So what I'm going to do, because it's the same, I'm not sure why that did that. Must have hit something. Is 45 meters squared. If I want the length and the width, I'm just going to take the square root of that. So 45, square root of 45 is 6.7. And so I get a square that's 6.7 by 6.7. What is the minimum perimeter? So the perimeter is 6.7 times 4, because we have 4 sides that are 6 by 7. I'll show you. And so I would just multiply that by 4. And I got 26.8. And that is the smallest perimeter that we can possibly have with that example. So really simple. If you have the perimeter, just divide it by 4 and then calculate to get one side and then calculate the area. If you're going the other way to find the minimum perimeter, take the square root of the area and then multiply the answer by 4 to get the perimeter. All right. Those are nice, simple examples, but you might be saying, what if it's more complicated? So we have an example for that. A rectangular garden is to be fenced using the wall of a house as one side of the garden. The garden should have an area of 40 meters squared. Determine the minimum perimeter and dimensions of the garden in the case that the dimensions must be whole numbers or meters. So in this case, I'm just going to draw it right now, but we have a wall. That's our wall. and we're going to build a garden out from it. So all we're really interested in is two of our widths and our length. And it has to be 40 meters squared. Determine the minimum perimeter. So when I'm looking at this, I'm thinking, what is going to make 40 meters? So I could do 1 by 40, where these are 1 and this is 40. I could do 2 by 20. 2, 2, and 20. And I can keep going all the way up to 40 by 1, which is going to look like this. 40, 40, and 1. Now there's a whole bunch of different examples like this. You guys can fill it in, and then we'll try to find the minimum perimeter. So I'm going to pause the video, and you guys can fill it in and see what you get, and then I'll see what I get, and I'll come back and I'll show you what I got. So here I've come up with all my different examples: 1 and 40, 2, 20, 4 and 10, 5 by 8, 8 by 5, 10 by 4, 20 by 2, and 40 by 1. Now notice in our case the width was 2 of them, just like this example here. So I'm going to use that to find the perimeter. So in this case, 40 on one side, 40 on the other, and 1 on the other. This becomes an 81 meter perimeter. So I'm going to do the same thing. This would be 42. This would be 24. And we can keep going. 16 plus 5 is 21. 18. This is 18 as well. 4 plus 24. And 42. So those are our different examples. And the question really says, determine the minimum perimeter. So in this case, we actually have 2 different cases for this one. You'll see this one works and this one works. So we can have one that's 8 by 5, and we can also have one that's 10 by 4. Both of those work, so we could say that we have 2 different options. That's a little bit interesting because we have that constraint. You have to be a little bit careful in terms of calculating your perimeter. Final example, we're going to try to enclose a non-rectangular area. A hobby farmer is creating a fenced exercise yard for her horses. She has 900 meters of flexible fencing and wishes to maximize the area. She's going to fence a rectangular or circular area. Determine which figure encloses the greater area. So we're going to do 2 different ones. We're going to do a rectangle, and we're going to do a circle. Now we know that the maximum area when we're dealing with rectangles is a square. So we're going to do that. We'll do the calculations for that first. It's 900 meters of flexible fencing. So I'm going to take the 900 and divide by 4, just like I did in the previous example. And I get 225. So each side of the square is going to be 225 meters. And then what we're going to do is figure out the area, which is length times width, in a square, which is 225 times 225. And in this case, we get an area that's 50,625 meters squared. So that is our area. Oh, I thought that would turn out better. Let's get rid of that. Let's just box it in so I have it. So that's the area of our square. Let's go to the circle. And in our case, the circle, to go around it is the circumference. And if you guys remember, circumference was equal to pi, 2 pi r, because we're going to need the radius for the, well, it doesn't matter actually. Let's go back to, let's use our diameter because it makes it nice and simple. Pi times d. So if we know that 900 is all around, we'll do 900, which is pi times d. I'm going to solve for d by just dividing both sides by pi. So 900 divided by pi is 286.4 across. 286.4 is the diameter. So we know the diameter is across. Our radius is half of that. So let's calculate that because we're going to need it to find our area. So that gives us a radius of 143.2 approximately. And then our area, if you remember, is pi r squared. So we'll calculate our area and we'll see if it's any bigger or smaller than the square that we have. So 143.2 squared times pi times pi is hold on. I calculated all at once. 64,422 approximately meters squared. So you can easily see that the circle gives a bigger area. So just be careful with these ones because the circle, you got to do a little bit of manipulation to find out what the R is or the radius so that you can actually use the formula. Similar to the square because we had to figure out what the length and width was before we could actually figure it out. But that is an example of shapes, a shape that can give you a potentially bigger area, but it isn't a square. Those are just some examples of how you're going to do the practice questions. I know this lesson was long. You may have to go back and watch it again. But good luck today, guys, and let me know if you have any questions.